Okay, we're going to look at our last example, which is example 3. And once again, this right here should say 2x squared. So the first thing you want to notice about this function is it's not in standard form because our x squared term isn't first. So I'm going to rewrite this as 2x squared because we want our x squared term first, and then our x term minus 8x, and then last our constant. So once it's in this form, then we can see that a equals 2, b equals -8, my equals are being weird, and c equals 9. So now let's find our axis of symmetry. We have negative of our b, which our b is -8, so -8 all over 2 times a, which is 2. So negative of -8 is +8. 2 times 2 is 4. So we end up with 2. So our axis of symmetry is x equals 2. Hopefully you're starting to get the hang of these. So we're going to plot our axis of symmetry. We're going to go to x equals 2. And we're going to make a straight line that's going to divide our parabola into 2, or right down the middle. Now for our vertex, we already know x equals 2, so we need to find out what y equals when x equals 2. So into our equation up here, wherever there's an x, we're going to substitute in that 2. So we're going to end up with 2 times 2 to the second power minus 8 times 2 plus 9. And when you do all that math, what you get is 1. So our vertex is, when x equals 2, y is 1. So it's 2 comma 1. So let's graph our vertex. I'm going to go over 2 and up 1. So our vertex is going to be, oh, my pen's not cooperating. There we go. Right there. There, that's a little better. 2 comma 1. Okay, so we found axis of symmetry, we found vertex, we need to find our y-intercept, which is always c, and we said c is 9, so 9 is our y-intercept. So then I'm going to plot this point this time. I'm going to go over to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our y-intercept is going to be way up there. I did it in a different color. Let's make it red. There we go. Okay, direction of opening. A is 2, which is positive, so our parabola is going to open up. If it opens up, then our vertex will be a minimum, and that minimum value will be at 1, because our vertex is 2, 1, and remember, the minimum value occurs at the y value. So you look at your vertex, whatever your y value is, that's where your max or min occurs. So our min is going to occur at y equals 1. Okay, I want to write our vertex. Oops, that's not the right vertex. Ignore that vertex. Our vertex is 2, 1. So I want to do 2 points to the right of 2, which would be 3 and 4. And then I just have to figure out when x equals 3, what does y equal? So I'm plugging 3 into our function this time. And I'm going to get 2 times 3 squared minus 8 times 3 plus 9. And that actually gives us 3. So there's a coordinate point, 3, 3. And then the next one is when x equals 4, y is going to equal 2 times 4 squared minus 8 times 4 plus 9. And that equals, let's see if I can squeeze that in, 9. So when x is 4, y is 9. All right, let's plot these points. Let's plot 3, 3. So over 3 up 1, 1, 2, 3. That's going to be right there. So that's 3, 3. And let's plot 4, 9. So over 4, that's 3, 4, 5, 6, 7, 8, 9. So that's right up here, right across from our y-intercept. So that's 4, 9. So now go to this 3, 3 point. It's 1 to the right of the axis of symmetry. So 1 to the left, I'm going to have another point. And up here, the 4, 9 is 2 to the right of our axis of symmetry, and 2 to the left, I'm going to have another point, which is actually our y-intercept. And so now I have 5 points, and I can sketch my parabola. So that is it for examples 1, 2, and 3. Now in your notes on page 8, you have a your turn problem. So the next thing you're going to do is try that your turn problem on your own. And then if you continue on in your notes to, let's see, the top of page 10 is 2.1 practice problems. You have 1, 2, 3 problems where you're graphing. And then 2 more problems, so 5 problems altogether. You're going to do those problems on pages 10 and 11. And those will be due at the beginning of class on Wednesday. That's all. Thank you.